All right, let's talk about something that comes up in pretty much every single Java interview, creating threads. Now, it sounds basic, right? But trust me, how you answer this one question can make or break your chances. It's a huge tell. So let's get right into it.
So, picture this. You're sitting in that interview chair, and the interviewer leans in and asks, "How do you create a thread in Java?" Seems easy enough, doesn't it? But oh man, the way you answer this tells them so much about how deep your Java knowledge really goes.
Yeah, because it's not really about just spitting out some code. Your answer is like a time machine. It shows the interviewer whether you're stuck back in the early days of Java or if you're up to date with the modern, super efficient ways of doing things. It's a test of your understanding of Java's evolution.
So let's start at the very beginning, with the two original methods for creating threads. You can think of these as the absolute building blocks that every Java developer learns first.
The first, and the most direct way, is to just make a class that extends Java's built-in thread class. This is probably the very first thing you ever saw in a textbook about threads. And it looks super simple, right? You just make a class, say myThread, and have it extend the thread class. You dump all your logic inside the run method, then you just create a new myThread object and call .start. Boom, new thread, easy peasy.
But, and this is a huge but, simple isn't always good. Here's the killer problem. Java only has single inheritance. So the second your class extends thread, that's it. It can't extend anything else, ever. You've completely locked it down. Plus, your task, the actual work you want to do, is now permanently stuck to the thread itself. It's what we call tight coupling, and in software design, that's a big no-no.
So the verdict here is pretty clear. While you absolutely have to know this method exists, you would never, ever use it for real production-level code. It's purely a legacy approach.
To fix all those problems, Java gave us a much, much better way, implementing the Runnable interface. And honestly, this was a huge leap forward for good software design.
Now look at this, it's a game changer. Our class, myTask, isn't a thread anymore. It's just a task, a piece of work. It implements the Runnable interface. Then we take that task and hand it over to a real thread object. You see what we did there? We separated the work from the worker.
And that separation is what makes it so powerful. Your task class is now totally free to extend some other class if you need it to. This is just fundamental object-oriented design, and it's why all the modern frameworks like Spring, for example, pretty much demand this approach.
And here's the money line for your interview. You say this, and they'll know you get it. Runnable decouples what to do from how to execute it.
I mean, just look at them side by side. It's not even a contest. When it comes to good design, inheritance, flexibility, Runnable wins every single time. It's just a way more professional and flexible approach. And if you want to sound extra smart, this is the core principle at play. It's composition over inheritance. We're composing a thread with a runnable task instead of locking ourselves into that rigid inheritance chain. It's just better software engineering.
Okay, let's fast forward a bit. In Java 5, everything changed. It was a total revolution for concurrent programming with a whole new toolkit of high-level utilities.
The first of these awesome new tools is the callable interface. Think of it like Runnable's bigger, stronger sibling. It was designed to solve two major headaches that Runnable had.
So what are those two headaches? Well, first, Runnable's run method returns void. It can't give you a result back. Callable's call method can. And second, run can't throw checked exceptions, which is a real pain for error handling. Callable, on the other hand, totally can, which makes your code so much cleaner.
So you might be asking, if a callable can return a result, how do I get it? The answer is an object called a future. When you go to run your callable, you don't wait for it. You immediately get back a future. It's like a receipt or a promise that the result is coming later. You can use that future to check if the job is done, or to just sit and wait for the final result to pop out.
And all of this leads us to the fourth, the final, and let's be clear, the absolute best practice in modern Java today, the executor service.
Okay, so this is where the entire mindset shifts. We stop thinking about creating one thread at a time. Instead, we think about managing a pool of worker threads. And that's exactly what an executor service does. It's like a manager that handles all the grunt work for you, creating threads, managing them, and this is the most important part, reusing them. Why is that a big deal? Because creating a new thread from scratch is actually a really expensive operation. Reusing existing ones is way faster. It's a massive performance boost, and it stops your application from just spinning up thousands of threads and crashing the whole system.
And that brings us to the modern rule of thumb. For any serious real-world application, you just don't create threads by hand anymore. You always use the ExecutorService framework, period.
Okay, so we've got the 4 methods down, but a good interviewer is going to hit you with a follow-up. They love this one because it shows if you actually understand what's happening under the hood. The question is, what really happens when you call the start method? Let's break it down. When you call start, you are not calling your run method. What you're really doing is telling the Java virtual machine, hey, I need a new thread. The JVM then talks to the operating system, gets a brand new native thread, sets up a fresh call stack just for it, and then marks it as ready to go. Only then does the JVM call your run method for you, but it makes sure it executes on that new, separate thread.
And this right here, this is the classic interview gotcha question, the one they use to trip people up. If you call t.start, you're kicking off real, actual multithreading. But if you call t.run directly, no new thread, not at all. You're just calling a method. It runs right then and there on the current thread, just like any other method call. It's not multithreading. It's just a plain old function call. All right, here's another quick one they might throw at you. What happens if you try to call start on the same thread object a second time?
The answer is a hard no. A thread can only be born once. Once it's started and finishes its job, it's done for good. You can't restart it. If you try, Java will immediately throw an illegal thread state exception right in your face.
Okay, let's put a bow on all of this. We've gone from the old school ways to the modern best practices. So how do you wrap all this knowledge into the perfect, job-winning interview answer? Your definitive answer is always to use the executor service. You explain that you define your tasks as either runnable or callable objects, and then you'd submit them to the service. Why? Because it gives you the absolute best performance, fantastic resource control, it scales beautifully, and it's just the safe, professional way to build a real application.
So at the end of the day, this whole thing tells a story, doesn't it? The story of how Java grew up. It went from this very manual, low-level way of doing things to this super smart, high-level executor framework. And the whole reason for that journey? To give us better performance, way better scalability, and a much safer way to write concurrent code. So when you're in that interview, it's not just about listing the 4 ways. It's about showing you understand why this evolution happened.